Problem 19 says to push W1 onto the stack. Recall that a push operation is the same thing as move W1 to W15 register indirect with post increment. This is because W15 functions as a stack pointer. So we're going to copy the value of W1 to the memory location pointed to by W15. W15 contains an 804, so 804 is being modified. W1 contains the value 806, so 806 is being written to location 804. So the new value of location 804 is 806. After that, write is done. We need to do the post increment. So W15 contains an 804, so we'll take 804, we'll add 2 to it because this is a word operation, and we're going to get an 806. You cannot do a byte operation with a push or pop operation. Problem 21 says to pop the top of the stack into W3. Recall that a pop operation is the same thing as saying move W15 register indirect with pre-decrement to W3. So the first thing that we're going to do is going to do a pre-decrement operation. It's all, remember, a pop is always a word, so we're going to subtract 2 from W15. W15 has an 804, so 804 minus 2 means the new value of W15 would be 802. At that point, we're going to copy what W15 is pointing at into W2. So W15 is pointing at memory location 802. Memory location 802 has the value FB80, so the new value of W3 is going to be FB80. Problem 27 asks us to implement the C function in PIC24 assembly language. The C function receives two parameters, 2 pointers that are both pointers to 8-bit card data types. This function has a temporary variable called ccar, and what this function does is it swaps the contents of these 2 strings. This while loop right here loops over the characters in string 1. This test is checking to see that it's not the end of the string that is not found in the null byte. The first line of the loop body copies the character pointed to by pointer 1 to a temporary location called ccar. Then it copies the character pointed to by string 2 over the top of string 1. Then it copies the character that was saved in the temporary character to string 2, and then it increments both pointers, and it keeps doing this until the end of string number 1 is reached. Do not be concerned when you're doing these problems if you do not fully understand what the C code is doing. All we ask you to do is to play the part of a human compiler, and translating this code to assembly language means you only have to understand what each statement does. That's what a compiler does. A compiler does not understand in totality what a C function actually does. It simply mechanically translates each line at a time to PIC24 assembly language. Before looking at this PIC24 implementation of the C function, let's review the rules for how parameters and local variables are allocated to registers. We're going to use W0 to W7 to pass parameters. So this first parameter here, pointer 1, is going to be passed in W0. The second parameter here, pointer 2, is going to be passed in W1. Any unused registers in this range can be used for local variables. So we're going to use register W2 to implement this local variable C_car. So our PIC24 implementation starts with a label that's going to be the same name as our subroutine. Now at this point we now need to begin implementing this while loop. So we'll do this test first, which compares the character pointed to by pointer 1 against 0. So we're going to use the compare 0 instruction. W0 contains this pointer, so register indirect will get the character that this pointer is pointing at. Now we need to implement this branch. Recall that we need the false branch here to skip this loop body if this test is not true. The false branch here is going to be the equal condition. So we'll do a branch on 0 to string swap exit and skip our loop body if our character is equal to 0. So if we get here, we're going to be here in the C function, so we need to do a return. We don't have to worry about what the value of W0 is. Remember, W0 is used for a function return value. This function here doesn't have a return value, so we'll just do a return at this point. If this branch is not taken, we'll begin executing the loop body. Let's implement this statement of the loop body, which says copy the character pointed to by pointer 1 into this temporary variable ccar. So we're going to do a move.byte. W0 indirect will get the character pointed to by pointer 1, and we need to copy that to W2, since that's used as a temporary as the register for this local variable C car. So that's going to implement this statement here. The next statement is going to copy what pointer 2 is pointing at to the memory location pointer 2 by pointer 1. So we'll do a move.byte. What pointer 2 is pointing at, we're using W1 for that, to the memory location pointer 2 by pointer 1, which is implemented by W0. At that point, we've just implemented that line right there. Now we need to do this final move here, in which we're going to take our character and our temporal and our local variable and copy it to the memory location pointer 2 by pointer 2. So W2 contains our local variable C car. We're going to copy that to the memory location pointer 2 by pointer 2, which is in W1, and we use the register indirect mode for that. At that point, this line is incremented, that line right there. Now we need to increment our 2 pointers. So we're going to increment W0, put the result in W0, increment W1, put the result in W1. And now at this point, we need to jump back up to the top of our loop. So we'll do a branch back up to the top of our loop. At this point, our solution is complete. We could save a couple lines in the solution by noting that this increment of W0 could actually be done as a post-increment addressing mode right here, while this increment of W1 could be implemented as a post-increment of this addressing mode right there. That would eliminate 2 instructions from this loop. For the C code of the previous problem, before converting this to a PIC24 assembly language, it can help to convert it first to an intermediate representation in which you replace all variables with their register equivalents. So for example, we know that W0 is going to hold the pointer 1 value. So that means a star pointer 1 can be represented by a W0 register indirect. So anywhere we have star pointer 1, we'll replace that by W0 register indirect. Same thing for pointer 2, which is being implemented by W1, where we'll replace that with a W1 register indirect. Anywhere where we have this local variable C car, we'll replace it by W2, since that's what we're using for C car. So in terms of these pointer incrementation, since we know pointer 1 and pointer 2 are both pointing to car data types, which is 1 byte wide in size, we know that is actually going to be an incrementation of that register value by 1. So here we replace W0 is equal to W0 plus 1. At this point, the correspondence between this C code and this assembly code becomes a bit clearer. This assignment statement right here is going to be implemented by this move.byte, in which we move a register W0 register indirect to W2. Similarly, for these other move statements, this move statement right here is going to be implemented by this move.byte, in which we're going to move register W2 to W1 register indirect. This incrementation of the register is simply implemented by this increment statement here. Increment W0, place the result in W0. Same thing for this increment statement here. Here we have some C code that is calling the function that we wrote in the previous page. We declared 2 strings S1 and S2, and we're passing them to the string swap function. Here's the PIC24 assembly language code that's going to implement this call. We need to pass the first parameter in W0, the second parameter in W1. So we're going to move the address of S1 to W0, the address of S2 to W1. At this point, our registers contain the correct parameters, so now we can simply call the function. This sample test question asks you to write PIC24 code for this C function. This C function is called maxArray. It's passed a pointer to an array of 16-bit signed data. It's also passed a second parameter that's going to be the number of elements in this array. Inside the function, we're going to have a temporary variable called max that we're going to initialize to the smallest 16-bit signed integer. We're then going to have a loop that's going to loop over the elements of this array. We're going to check to see if our length is 0. If it's not 0, we're still processing elements. So this if statement here is going to read a value via the pointer out of the array, compare it against our maximum value. If it's greater than that, it's going to record that array element as our new maximum value. It's then going to increment our pointer to point to the next array element, and we're going to decrement our length, which tells us how many more elements we have to process. When we exit the loop here, this temporary variable max is going to contain the maximum value found in this array. To implement this code, we know that our first parameter, which is the pointer, is passing W0. Our second parameter is going to be passing W1. We're going to use W2 to implement this temporary variable max. So we're going to have a label here that's going to be the name of our subroutine. We're now going to initialize W2, which is max, to a negative 32768. You could write that as hex, which is 0x8000, or you could let the assembler do that for us. We're now going to begin implementing this while loop. So we're going to mark the top of our loop, and we're going to compare our length against 0. So we're going to compare W1, which has our length variable, against 0. To exit this loop, we're going to need the false branch, which is going to be the equal. So we're going to branch on 0 to max array exit. If this loop branch is not taken, then it means that we're going to need to implement, that we're going to execute the body of our loop. So to implement this if test, we're going to compare what our data is pointing at against I16 max. So we used W0 to contain this pointer, so we're going to do a compare W0 indirect. That's going to get what W0 is pointing at, so get that array element. We're going to compare it against W2. W2 is our temporary value max. At that point, we now need to implement this branch. We're going to skip the if body. This is the if body. We're going to skip this if body. We need the false branch, and so the false branch for the greater than is going to be a less than or equal. This is signed data, so we need the signed version of this branch. So we'll do branch on less than or equal to endf. And we're going to skip the statement that implements the loop body. If this branch is not taken, then we need to execute the statement that implements this. That statement is going to copy the data that our pointer is pointing at into our max variable. So we're going to do a move in which we're going to, W0 has this pointer, we're going to do move W0 indirect. That's going to grab the data this is pointing at, and we're going to copy that to W2, which is implementing max. We saw that the if statement here was implemented by these three statements here. So now at this point we're ready to implement our pointer incrementation. We're going to increment W0, which contains our pointer, by 2 and store the result into W0. Why are we incrementing by 2? Recall that this pointer arithmetic is actually doing plus 1 times the size and byte of what this pointer is pointing at. This data is pointing at a 16-bit data, so that's 2 bytes. So it's actually adding 1 times 2 is adding 2 to this pointer value. So that's why we need to increment W0 by 2 and then write the result to W2. We now need to decrement length. Length is stored in W1, so we're going to decrement W1 and write the result back to W1. We're now at the end of our loop, so we're going to branch back up to the top of our loop. At this point, we're at the end of our loop and ready to return our C function value. Recall that we return that our rules say that any C function value is going to return in W0 if it's a 16-bit value. This max is actually sitting in W2. So what we're going to do is we're going to say move W2 to W0 to set up this return value, and then we're going to go ahead and do our return. At that point, we finish solving this problem. You may be tempted to try to optimize the solution by deleting this increment 2 here and putting a plus plus auto increment there or plus plus post increment there. The problem with this is that neither of these are going to provide the correct solution. Let's first do a plus plus here. If we do this, then it will, in fact, because it's a word operation, increment W0 by 2 after this comparison is done. But the problem with that is that when we go to implement this, to execute this statement here, which is the if body, we're now pointing to the next array element, where indeed we want to be pointing at the old array element that was used in this comparison. So this isn't going to work. If we put the plus plus here and delete our increment 2, then as long as the if body is executed, everything is fine. But what if the if body is skipped, which it can occasionally do? If it does, then we're still, W0 has not been advanced to the next array element, and so we're still left pointing at an old array element, and will process an array element more than once. So that won't work either. So we need to keep this increment to statement. This slide shows the C code of the previous problem written in an intermediate form in which our variables in the C code have been replaced by the register equivalents. Since we know that I16 max is being implemented by W2, we replaced all occurrences of I16 max with W2. We know that the length variable is being passed in W1, so all occurrences of it have been replaced by W1. And finally, we know that the pointer variable for data is being passed in W0, so star data is being replaced by W0 register indirect. At this point, it's a little bit easier to see the correspondence between this code and the assembly code here. We're assigning the value negative 32768 to W2, so we're going to move that immediate value in W2 here. This if body assignment right here is implemented by this assignment statement right here, in which we're going to be copying register indirect W0 to W2. This point incrementation, we know that since this is pointing to 16-bit data, the size of a 16-bit data is 2 bytes. So we know that that W0 pointer is going to be actually incremented by 2. So and that's going to be implemented by this increment 2 statement. This slide shows some C code that calls the C function of the previous slide. Here we have an array Y that contains 4 elements, and we have a 16-bit variable called maxval. We're going to call the C function of the previous slide, passing it the address of this array along with the number of elements in the array, which is 4. We're going to save its return value in this variable maxval. The PIC24 code that implements this is shown here. First, we're going to pass the address of array Y into W0. We're going to copy 4 into W1. Now that our parameters are set up, we can call the subroutine. On return, we know that W0 has the return value of the C function, so we're going to copy that into our variable maxval.